Have you ever picked a leaf off the tree? Me too. But after this video, you will appreciate it because the way it maintains life is a very important process to the planet Earth called the photosynthesis. Plants absorb carbon dioxide, water, and light. They are experts at capturing sunlight and convert it into chemical energy stored in the form of carbohydrate molecules. The color that we can see is a little part of the electromagnetic spectrum. Trees absorb red and blue light effectively and reflect small green light by the main pigment called the chlorophyll. The atomic magnesium center and bonds are able to receive energy from light. Light behaves both as a wave and a particle called photon. The energy is inversely proportional to the wavelength. So this is a leaf. In a single cell, there are 10 to 50 chloroplasts. The factories work so hard in order to create energy and food for our plants to grow up, and there are two reactions that happen here. Light reaction occurs in the thylakoid membrane, which is formed with complexes of proteins and molecules. A reaction happens with the catalysis of enzyme. There are two main centers. In the photosynthesis too, the chlorophyll captures the photon energy, and once a pair of electrons receive enough energy, they start traveling. These two guys get really excited. Passing from molecule to molecule, they interact and attract the girls out there, the hydrogen protons. They lose the power to get the hydrogen protons pulled into the lumen. In other case, they create a huge concentration of them. This water space is not comfortable at all. They want to go back into the stroma. So this concentration is used to write the ATP synthase because they can go through the membrane. ATP synthase mechanically turns at the top part, put ATP and phosphate group together to reduce ATP, since the high potential energy is stored in the bonds of the molecule. Arriving at the photosynthesis 1, the electrons are re-energized. They travel to the AMTP reductase. The NADP is reduced by gaining electrons and the A+, finally becoming NADPH. The NADPH and ATP are launched into the metabolic pathway in the stroma for the drug reaction. But hold on, can we just borrow their electrons from the pigment all the time? No, we need to give them back. But how? Alright, here's the water molecule. It will donate 2 electrons to replace the taken excited electron at first. It releases 2 more A+ to the lumen and oxygen atom. And what you guess is oxygen gas is created. Dot reaction occurs in the stroma. First is the carbon fixation. With rosical enzyme, carbon dioxide combines with the ribulose 1,5-bisphosphate and becomes 6 carbon chemical, immediately divides into 2,3 carbon chemicals. In the second step, electrons from NADPH and some ATP molecules are used to reduce PGA to make 2-glycerolic dihydrate-3-phosphate. And the final step, ribulose 1,5-bisphosphate is regenerated. After running for 3 times, 6 G3B molecules are made. 5 of them are used to reform 3 ribulose 1,5-bisphosphate molecules, and 6 times running 2 3-B molecules to make glucophosphate molecule. Plants absorb carbon dioxide to balance the atmosphere. Without these projects, oxygen would have run out. It also produces carbohydrate, which is food and materials for humans and animals. The mechanism is incredible, and people learn from it to create green electricity and machines now and in the near future.